So if we have known how monomers of ethene add up to give us a big polymer of polyethene, then polymerization is like that. So in those factories, they have things that look like tanks. What is there is just adjusted conditions to make sure that something comes out. So if all that thing happens, then industries are in position to produce everything that looks like that. Now, you look. Last time we looked at was it called cracking? Yes.
Yes.
We looked at two things. We had thermal cracking, and then we looked at catalytic cracking. Now, all these big complex molecules are broken down into small molecules. Now, when you get a big one, the end product is always these small molecules here. One of them is alkene, another one is an alkane. That's what we call cracking, breaking down big complex molecules to give us the small ones. You can either use thermal heat or a catalyst. You must know an example of a catalyst used for cracking them for now or as per now, and then the products formed. So when they tell you about cracking, don't question people, what is cracking in organic chemistry? What is polymerization in organic chemistry? Okay? You must be knowing them, and they should be at your fingertips. There are about 4 things to know here. You must know the compound you are dealing with. After knowing the compound, you must know its reactions. And then some of the reactions are here, either cracking to give us small ones or polymerization, small ones combined to form one big one. And then you must know how to write the general compound or the general formula. So you must know the functional group, what is responsible for the functioning of that element, and then which homologous series it belongs. Homologous series it belongs. Alkanes are saturated hydrocarbons, that's where they belong. Their function, what is responsible for the function is that single bond. And then alkenes, their homologous series is unsaturated. They have their general formula, you must be knowing for now. Then the functional group is because of attaining that double bond. Always that double bond cracks or it is removed from the reaction when it undergoes several reactions. We have looked at them. Polymerization is there, many of them, and then you finish up like that. So this ethene gas, this is the additional polymerization undergone by ethene. Additional is small molecules but unsaturated, small but unsaturated. That's when you are defining additional polymerization. Because you will be asked to differentiate between additional polymerization and condensation polymerization. You must know that in addition, small but unsaturated molecules of the same element combine to form a large molecule without any other products. But with condensation, we shall have 2 different molecules combining to form one large molecule with a consequent loss of either a simple water molecule or a hydrogen chloride and many others. So if you see a reaction that at the end of the day gives you water, you know that that is condensation, polymerization. So that is what we form there. We looked at the types of polymers. Polymers can be broadly divided into 2. Natural, those ones that occur naturally. We can't form them. It is from them that we get others. An example is starch. Starch, you can get it from many elements. We have seen from starch, we are now getting what? This and this. There are many, about 20, now there are 17. So here, here we look at starch. We have seen that it's from starch that we are getting even this sanitizer we are using. After getting the alcohol, they are fixing it in some starch so that it becomes heavy. If you press, it just comes onto your hand. It is from that starch that you get the alcohol you use and many others. So starch is the natural polymer. Proteins, amino acids, it prepares many proteins. That is the main element in protein is that amino acid. And the one that is responsible for wear, repairing the worn out tissues of the body. Cellulose, we get them from glucose. They are for the cell walls. In biology, you must know what is responsible for the rigidity of the cell. Do you know it? Huh? Yes?
Teacher, pardon?
What is responsible for the rigidity of the cells?
Proteins.
It is proteins, really. Even when you cut chicken, there's that yellow layer you always get there. What is the name of that yellow layer? Finished. It is part of those cells that are there. Even human cells has that yellow alignment. That yellow, is it called yellow what? Something that's yellowish in color. Like the egg has the yolk inside. No, that one should not be the one responsible for that. But in any living thing, that cellulose is always there. Glycogen, glucose is a source of energy. Lipids, fats is also a source of energy. Like for those people who like eating a lot of fats, the body can keep them. And then when you don't eat for a certain time, that's what the body generates to give you energy to move. So natural rubber is isopropyl. It is used for making footwears. Example, the what? What's the common name they use in Uganda? Those footwears they use. They are called what? Nigina. Linet.
Yes, teacher.
In your language, how do you call those footwears?
I don't know.
Because Baganda calls them Nigina. Who is a Muteso from here? So there are many, there are as many as you can. So those are the type of natural polymers we have. Now we are going to see synthetic polymers, artificial, man-made. One is polythene. Human, so that it's not hard to, it's not good to carry sugar in the hands as you are going. So they look for ways of making sure you carry sugar easily home. Instead, I think those days you used to go to the shop with a bucket. You wear and they pour you go away. So nowadays they say, let's look for something that is easy for you to carry and go. But again, in the long run, it is affecting the environment. So now they are looking for other ways of making sure that that thing disappears, which has become hard for all of us and for all of them. So polyvinyl chloride, the monomer for polythene is ethene. Polyvinyl chloride. So the monomer here is the chloroethene. You have seen here, chloroethene. This one is used for making raincoats, electrical insulators, making pipes and films. So here, ethene is used for making plastic bowls. You have seen those plastic bowls, or wrapping material. That one people use. There are people here who do home management. They always use that paper for wrapping. Is it a cake or what? Or foodstuffs. That is part of polythene. Then polyvinyl chloride. It is chloroethane that they use. So you see ethene, the uses of ethene, it is continuous. So the monomer here is chloroethane. So if you combine many of them, they give us what we call polyvinyl chloride, in simple terms, PVC. An example is a raincoat. Do you know how a raincoat is heavy? Huh? Is it heavy or light? A raincoat. You don't know raincoat. You don't know raincoat.
It's light.
It is a light, but it doesn't allow water to penetrate, isn't it?
Yes.
So that is the insulating part of that. It doesn't allow water to penetrate through. So electrical insulators, there are many. Making pipes, those ones are many. And then we have polystyrene. Polystyrene, the polymer, always when they ask for this, hey, somebody is making noise on the ground. Please mute your microphone if you are not using it. Okay. So polystyrene, the monomer is derived from this polystyrene. Styrene is here. Styrene. So that is, it comes from that polymer of polystyrene. That's the monomer they use. They use styrene. Now this one is used for making packaging material, making household items such as combs, plastic cups, and most linings in the refrigerators. There is that plastic that you normally find the linings of the refrigerators, or making packaging material. In simple terms, like the one for milk, that's what they use. This jesa or any other. Those are packaging materials. Household materials like combs, those ones used for scratching the head. Then now, classes of additional polymerization. We have particular classes of additional polymers. There are mainly two classes of this. We have only plastics and rubber. Now, when you look at plastics alone, plastics, we say a plastic is a substance which when soft can be formed into different shapes. That's the difference, the definition of plastic. Any substance which when soft can be changed to another shape. Now, if you get that comb you use and put it on fire, it can melt or it can turn into a liquid or something that's liquid or melt. It can melt. So when it melts, you can also use your own hands and you make another substance from it, or you use any other thing, any shape you want, and it turns to be like that. You can even turn into small balls and throw them there on the ground. That is a plastic. So plastics are minor products formed by cracking of crude oils, e.g. polythene, polyvinyl chloride, melamine. Do you know the melamine? Who knows melamine?
Yes.
You know melamine. Where is it and where is it from?
It's used for making, it's like plastic that breaks.
Plastic that breaks.
Used for making plates.
These plates we normally use for eating, they are not from clay. So what you mean to say they use melamine? Huh?
Teacher, those ones, they look like glass, but they don't break.
They don't break. So when you go for parties, there are those plastic plates they normally bring, disposable plates. Are they part of melamine? Where are people who are talking? I want to hear them. Those plastic plates you normally use in parties, are they part of melamine?
No.
So make us understand what is melamine and where is it used?
It's like it's plastic. It can melt and break and break.
Easily. Yeah, there are some plates that are made of melamine that they don't have clay in them. Actually, they are light. They look like clay, as if they use clay for making them, but they are always there. Light. The ones of clay are heavier than those ones of melamine. Okay, so there are many uses of that. So all synthetic polymers are plastic in nature. All of them, those ones that are man-made, they are synthetic in nature. Plastics are man-made and therefore they retain that name. They are called synthetic what? Polymers. Advantages of plastics, there are many. They are good thermal and electrical insulators. They can easily be shaped and molded, therefore they are ductile. They are resistant to acids or alkalis, they don't rust. That is a good thing with plastics. Even acids, to penetrate them is hard. Plastics can be colored when they are manufactured, when they are being manufactured. So you put in a colorizer in that mixture and that color you gives a definite color of the plastic. You see plastic cups that are red, purple, all of them are there. So they are light and therefore portable. An example is a plastic chair. You can carry it from here up to your village, but a wooden chair, after 2 seconds, you'll be forced to rest. So they are cheap. That is the advantages. Disadvantages is they produce poisonous fumes when they are burnt. They are non-biodegradable. They cannot be eaten by the termites or something else, or they cannot be changed into useful substances in the environment. So that's what we call biodegradable. So where serious fire hazards occur and you're near plastic, you better run away because that thing, when it spills on your body, it cannot leave the body in the same condition it was. It will burn you properly. Actually, I saw mothers those days when they want to punish a child, they get a cavera and tie the child properly and start, how do you call it? Okutonyeza. It's called what in English? They put that cover on your legs there and they burn. You see what will happen. So here there are two types of plastics. There are only two types of plastics. We have what we call thermo softening plastics, and then the thermosetting, thermo softening, and then the thermosets, thermosetting. We want to finish this, and then next time we meet, we shall look at alcohols. Those who are interested in alcohol, please look for ways of preparing alcohol locally at home, and you come and tell us. There are those who do the one from the village called Mwenge Bigere. There are those ones from Lira. They have El Kuluje. There are very many. So you come and narrate for us how those things come about. Then you shall tell you the one that's produced industrially. Those ones, the jeans. That one is there. So here, let us look at one type, and then next time we meet, we shall look at the other type, because I see we have 2 minutes left. You have another lesson after this, isn't it?
No.
Yes, teacher.
No, we don't.
Hey, who is this one? Please, you have another lesson. Yeah.
For the form series.
Unless for the form series. So this is
I have another lesson.
very good. So we have a few minutes to stop this lesson, and then we'll see what to do next. Next time we meet, we shall look at those ones, alcohols and the different plastics we have. The first one is called thermo softening plastics or thermoplastics. These are plastics that soften or melt when heated and can be therefore molded into another shape while they are still soft. Okay, those are the thermal softening. The name is already there, thermal softening. You can heat, after heating it, it can be made into another shape in simple terms. So an example is a plastic cup. You can burn that cup, it turns into, okay, it melts. After melting, you can turn it into something else you want. Those are the thermal softening plastics. These ones are different from the thermosets. Thermosetting, once it has set, it has set. You cannot change it to another form. That's the only difference they have. So if you want to change it to another form, you are spoiling the shape. Okay? So that is what we had for today in our discussion. Anything else you want to know? If there's nothing, somebody should come and tell us yes.
Some of us don't have those notes.
These ones, you don't have them.